Oh, great.
We're live.
We are.
This is the
Now you tell me.
AI Across the Product Lifecycle podcast, and I have a special edition because I have two pioneers in the industrial manufacturing space. I have Thomas, who created a protocol that he's going to explain called OPCUA, which is fundamental for getting information out of devices. And we have Arlen, who created MQTT, which is a protocol sitting on top of the TCP stack, also used for getting stuff from devices. We're going to compare, contrast. So anyway, Arlen, why don't you give us a little introduction?
Okay. So, hello, everybody. Arlen Nipper. I'm the
Who's getting a
president.
lifetime award tomorrow?
I do get a lifetime award tomorrow. So, I'm the president and CTO of SiriusLink Solutions. I've been doing industrial automation for 48 years. Um, Through my career, exactly 26 years ago, working on a project with Phillips 66 in Bartlesville, Oklahoma. They had just gotten a brand new TCP/IP based VSAT system. Now, the cool thing is that you had Gilat, you had Scientific Atlanta, you had all of these VSAT companies, but they had proprietary backhauls. So you were always playing these protocol games to try to get data out of the field back into the control system. But and you have to realize 1999, TCP/IP, although it was around, it wasn't prevalent in the industrial world. It was DEC, it was IBM, but we had this network now. Now Phillips 66 were controlling 9,000 miles of pipeline, and they were still using conventional pole response protocols. And it took them 15 minutes to go all the way around to pole their pipeline, all their booster stations. And plus, they were using 100% of their bandwidth on the VSAT, and it was very expensive. Steve Koenig was the SCADA manager at Philips. He had a good friend that was the IT manager, and he said, "Hey, Steve, we've got this new system. It's called IBM MQ series. It's message-oriented middleware, and it decouples our IT applications by publishing information to a broker, and then other applications can subscribe to it."
Pops up.
So Steve got to thinking about it, and he came to me and said, "Hey, could we publish instead of polling all the booster stations? Couldn't we just publish information as it changed?" And I go, "It's a good idea." And then he got a hold of the guys at IBM, and Andy Stanford Clark was an IBM fellow at IBM. He flew over to Bartlesville, and we got together. We started talking about it, and we took big, huge IBM MQ, and we kind of set the goal. Is that okay? Every byte on the wire is $50,000 a year to Philips. And so he would come in and say, "Hey, in the shower this morning, I figured out how to save another $100,000." And it got smaller and tighter, so that MQTT, the overhead of the transport, once you establish a session, is 2 bytes. And by using report by exception over MQTT, we took that 15-minute time to get all their data in down to less than 5 seconds, and using 90% less bandwidth over the VSAT. So that story was the genesis of why MQTT was invented.
What's the TT? Is it a message queue?
Message queue, MQ series. So it was MQ
There's message queue.
message queue. Yep.
But the TT,
Telemetry transport.
there you go. Telemetry
It's-
transport.
Better just say MQTT. It's a lot easier.
Yeah, it really MQTT has international standards, and it uses the OASIS standards body.
Right.
And in the last iteration, I think we all agreed that it's just MQTT.
And it sits on top of the TCP stack.
Yeah. And
As
so
we were saying before the call, the security is already built in.
right. And so the reason now today, like Walker Reynolds said, there's 70 billion MQTT clients in the world. When Andy and I did this, we just decided that we were going to establish the connection from the remote side. So that's an outbound IP connection.
to publish.
There's no ports open. So if you're a manufacturer, if you're trying to do something, IT goes, "Well, gee, we're going to do a scan of all the open ports. There's no ports open. And so it came into the fact that with us setting on TCP/IP, with us using remote originated connection, and then technology like TLS, now if security changes tomorrow, and that's going to be a problem with OPC. If security changes tomorrow and somebody found a vulnerability, we'll be able to ride right on top of the latest TCP/IP technology.
Very good.
He just give you a challenge there.
I,
Tom.
I don't know that I can compete with Arlen because he really can go into a lot more detail. But so let me tell you why we created OPC though. At the time, it was all about how do we get connections to all these different devices and networks that were out there. And I was familiar with all these networks. Now at the time, we couldn't say the word Ethernet. If I were to go to GM and Ford, that scared the daylights out of them for some strange reason. They were so used to proprietary networks that they didn't want to have anything that was a standard. So we worked around that. But OPC was really created to solve a problem of multi-vendor interoperability. And when we first did this, Michael, it was all about, it was Rockwell, it was Opto 22, it was a company called Fisher Rosemont that ultimately became Emerson. And then there was a software company called Inolution, which has been absorbed multiple times. So there was the four companies, and we all decided that we wanted to have connectivity. Rockwell really wanted to be able to talk to more than just Rockwell devices. We were good at talking to Rockwell. Siemens wanted to talk to more than just Siemens devices. So OPC was created for a reason. It was a very simple, it was known as OPC Data Access. I created it in 1995. We did it within 6 months. But again, it was a client server model. And the whole goal was it was multi-vendor interoperability. So I've been quoted, Michael, a million times. Success is measured by the level of adoption. And the key was it was adopted and well entrenched into the technology. And of course, a good standard never stops. It continues to evolve over a period of time. So ultimately what we developed was, initially we were very tied to Microsoft. And that life was good. Microsoft was a great provider. So OPC stood for OLE, for process control. And the funny story was I used to ride around with a Mexican hat and say, ole, ole. But OLE stood for object embedding.
Yeah.
And what it was the concept that we used for Microsoft was the ability, for example, if you had a Microsoft Word document, you could actually have Excel inside the Microsoft Word document. And that was what the object linking embedding was. So as you change your Excel spreadsheet, it would change in the Word document. So now imagine we took a look at that technology and we put it into OPC, and it was known as COM. Then
and
we
the
did
PC?
it. Yeah, that was OPC.
No, with the P is protocol?
Yeah, OLE for process
protocol?
control.
Process control.
OLE for
Gotcha.
process, object linking embedding for process control.
Gotcha.
Now we just
And
call
then you
it
had
OPC.
DA and UA after that. User
And
access
then we had
was
DA, and then UA was the unified architecture because I decided to break away from life was good with Microsoft, and I love Microsoft, but how did we start doing things on other platforms
Unix and
that weren't Microsoft, right? Like Unix, for example. Like putting yourself into a different arena, like putting it into embedded devices. Okay, and that was kind of the key. So that was the purpose of the unified architecture. And with that, we've continued to evolve that to collaborate with a lot of organizations because we wanted to take data from all these different organizations. And like ISA 95 was something that was very important in the industry at the time. So we were able to take ISA 95 and provide both the syntax and the semantics of the data, leveraging that kind of thing. So, but OPC was an interesting ride. I created it in 1995. It was 4 companies that did it. At the time, some of these companies had their own proprietary ways of talking to it. We created actually a cottage industry. People started building OPC servers, and the OPC server had the ability to talk to all these different devices. So, Inductive, for example, had a whole, did all their device drivers, right? And they used the OPC functionality at times. That's how I actually met Inductive to begin with back in 2003, and I got to know Colby Clegg from Inductive. He came to one of our interoperability workshops, and but it was all about multi-vendor interoperability. That was the key. The end users liked it, but then as we moved into a further direction, I started recognizing, and that's when I first met Arlen, like we got to do something about publishing data. How do we make that work? And really at the time, OPC UA should have done, basically used MQTT as the publishing broker at the time. We did some other things. We did it our OPC did it our own way. Looking back, I wish we would have found it on the table and done that. But
Would it be inaccurate to think of analogy of TCP and UDP? But
yeah,
you were
it is.
doing TCP and you were doing UDP more or less, or
It's the other way around.
the other way around.
Yeah,
Yep.
the other way around. But that's okay.
So as the industry shifts towards more distributed, event-driven, and cloud-connected systems, how do OPC UA and MQT complement each other rather than compete?
Well, we again, like Tom gave a good example, the inductive automation ignition platform. It leverages the heck out of OPC UA. That's how we connect to devices that already talk OPC. And to Tom's point, there's software out there like Kepware. And
Yeah.
I would argue there's probably more OPC implemented in protocol converters than actually on devices.
Oh yeah, yeah.
So really it became a protocol converter layer. But the problem with OPC is you've got to you got to open ports, you've got to get all of this connectivity up and running, and it's really more of a high-speed, reliable poll response network. Well, then when you start moving off of the enterprise, and again, I said one of the big advantages was MQTT, we don't have to open any ports. And we can just go out there and it's very easy. It's the beauty of MQTT is the entire spec was 18 pages long. It's really super simple. And you can publish anything you want on any topic. We didn't dictate a payload. We didn't dictate how you did your namespace. Now, later I will talk about Sparkplug, where we, the good thing is you can publish anything you want on any topic with MQTT. The bad thing is you can publish anything you want on any topic. So we have started developing specifications that help control that. But again, to my point of the 70 billion clients out there
Right.
today, from connected cars to robotic surgery. I had appendix cancer last year, and I found out I'm good. They got it all, but the robot they used on me was a Da Vinci 5 robotic surgery. Yeah, cool,
Wow.
I healed. But 3 months later, I'm talking with Snowflake to this company called Intrinsic Machines, and they go, yeah, we need MQTT because our robotic surgery devices publish every move up to the cloud using MQTT. So they could do an audit trail on my surgery. So it's places that you wouldn't even think about it, but it makes it very easy, lightweight, and again, since it is event driven, you're looking at 80 to 95% less bandwidth usage.
And did you ever get that 5 seconds even closer?
Oh yeah, I mean,
Couple
on
milliseconds now,
factory
right?
floors now, we're down in the milliseconds, but we couldn't get that much further down because remember, there's 500 milliseconds propagation delay
Yeah.
to the satellite, and then 500 milliseconds coming back, so on and so forth.
Oh,
So,
it's,
so Michael, so OPC was designed for multi-vendor interoperability. It really was about leveling the playing field. We didn't want to have all these different, getting locked into a single vendor. And that was the problem. Now, as some of the companies realized, well, maybe that wasn't a good thing. So now I didn't only have to use Rockwell anymore. I could switch to Siemens. I
Yeah.
could switch to Beckhoff. So, it kind of, grew the industry. And a lot of these companies, Darwin's point, some of these companies, the idea behind OPC initially was that Rockwell would write the best OPC server to talk to Rockwell. The reality was Kepware did a better job than Rockwell.
Yep.
And I can tell that, and I was working for Rockwell at the time, but Kepware did a better job. And a lot of these other companies started writing these OPC servers to communicate to a vast variety of different devices, right? So it wasn't just PLCs. It was like, and you know, the reason like we partnered with Opto 22, they were an IO company, but we were able to talk to all their IO devices via OPC, and that was kind of the mentality behind it. We never really belonged in the published business. That was really more of MQTT. So, you know, I
Mhm.
don't ever think that we compete.
No,
I think there's a place for both technologies, right?
absolutely.
You know, but OPC's designed as more of a client server, as Arlen said. We go out and grab the data. Somebody writes an OPC server that talks to these different devices, grabs the data, and makes the data available, right? And you know that's with everything we're talking about, Michael, in the world of AI now, the thing that AI needs the most is it needs data. Without the data, it's useless. I mean, you run, you know, all these and analyzing what? You know, your bad data in gives you bad
Garbage in,
information
garbage
out.
Right.
It's garbage in,
Right.
garbage out. So
And
That's
so,
a great segue to that question.
well,
So how is AI?
so to kind of segue to that, I mean, I'm thrilled that at this conference, everybody's talking about MQTT. It's, you know, and then I mentioned that we have a specification called Sparkplug that helps industrial data be published in the right way. So you've got a process variable. That process variable is temperature, its engineering units are degrees C, so on and so forth. But the thing that really excites me, if like Opto 22, we're getting down, or Phoenix Contact, or all these other device manufacturers, Baldor with their IO Link, is getting down to the point where MQTT is so lightweight that we can embed that intelligence in the sensor. It knows what it's doing, and one of the big things now for MQTT is we're promoting is we provide a single source of truth from the edge, because with everything else, even with OPC, typical OPC, you got to register value back. Oh, well, that's an analog value. We have to convert it from 0 to 1024 to 0 to 100 degrees, and we don't know what the engineering units are. So a human being had to hand enter all that. But we are to the point now where we should have devices connect, publish their data, and go, oh, look, something else showed up, and now we can take advantage of it. Then that single source of truth, then is what you need to feed into AI.
and so I'm a big fan of, you know, data at the lowest level. The device knows at the lowest level what's changing, what's important. Let's use a standard that allows me to push that data out at the lowest level. MQTT is the perfect solution for that. So I can put MQTT down, as Arlen said, into the lowest device and push that data up, get it into whatever system. And, you know, it's like an announcement was made this week. I decided to join inductive automation this week. I am now, you know, the technical evangelist for inductive automation. And it's a perfect fit because I like what they're doing. I think it's a really good fit. And I think the industry is going to change a lot as we look at, and again, inductive believes in multi-vendor interoperability. They're not trying to do everything. And they believe with having alliances with a lot of other companies and the importance of, you know, I was the OPC guy, but I embrace MQTT because there's a lot of power in, you know, going down to the lowest level, putting it down there, it knows what to push up. Push
And
up
it
the
can
data.
gather a lot of context,
Yeah.
Yep.
Go.
which is so important to the whole AI story. And I guess it's also that addresses one of the other questions, which was how the way we think of devices, how we're creating industrial equipment is changing. It's
Yes,
evolving.
absolutely. Now, you know, we were actually, Tom and I were talking about this morning about you probably got more compute power on an Arduino than
Yeah.
NASA had on the lunar
Space shuttle.
excursion module. But yeah, I can't. There's a couple of device manufacturers I can't mention today, but they came by the Sparkplug booth, and they are all looking at embedding Sparkplug right in to give themselves added value, because if you think about it, with a platform like Ignition, I could get all these sensors, connect them, put them on my securely on my TCP/IP infrastructure, not knowing a thing about them, flip on Ignition, and 2 seconds later, I've got 10,000 process variables and everything's contextually right.
And
Amazing.
as he said, securely. So security now, and for your audience, security is a big topic now.
Huge.
You may not think it is, but it is, and
Oh,
you
no, I
want to
do
make
think
sure
so.
that only the right
Yep.
people are accessing the data.
Like
For
I'm in the
example,
engineering world, security is.
I don't want to know your payroll information, and you don't need to know. We may want to know it anyway, but
Out of
there's
just
information that
curiosity.
you want to get protected. And Darlin's point about like in the medical industry, there's a lot of rules in whatever country you're in that talks about your information shouldn't be made available to only the people you want it available
Right.
to. And that's the power of what we're trying to do.
Well, I don't come from this manufacturing world. I've dabbled in it a little bit. I was with a PTC reseller doing sadly ThemeWorks, but it is what it is. But I'm really surprised at this show. It seems to me in a lot of ways manufacturing's even past a lot of the things we do in engineering. That demonstration of inductive where they just pushed out the entire factory in 3 minutes was mind blowing. I mean, to see Kubernetes in an industrial context, it was just crazy.
Well,
The
they
world is changing.
yeah,
I
they
mean, we were
inductive really
talking
broke
earlier,
the
like,
rules on that.
Who would
Yeah.
have ever thought, Michael, that I'd be able to pick up my phone and I'd be able to talk to my kids and see my kids, right? When we were younger, that
Yeah, we
couldn't
just
happen.
had the
There was
old
no network. The
backlight.
network couldn't handle that. Now, and to Arlen's point, the network, we still want to be able to optimize the data on the network, right? You really want to. Granted, the networks are a lot faster now, but when you can publish data, like what MQTT does, that optimizes the use of the network
Well,
far more
yeah.
efficiently.
My favorite saying that in operations, in
OT.
whatever, bandwidth is neither free nor unlimited. You
Yeah.
can't. Nobody says, "Oh, I have unlimited bandwidth and it's all free." No, every byte costs money. Not $50,000, but every byte costs money.
I think the thing I've really been impressed with is I hadn't realized how much it was needed to move some of the things we've done on the IT side into the OT world, and that's really what I've seen at the show is all these IT stuff.
Yep.
It reminds me of I had a friend of mine that was working on mainframes, and he made a lot of money in 2000 because I was like, why did you even have this year 2000? Probably because a byte was a lot. So if I could save it by just going to 1999, I wasn't going to flip that first bit because that was going to cost me another bit. So I was like, okay.
No, that's it.
One of the things
To your point about everybody counts.
Yep.
So one of the things that we're really working on, though, is making sure the voice of the customer. We want to make sure that in every industry, we're doing the right thing for the customer. So, we want to help them use the technology most appropriate. And there's a lot of cool technology that's out there, and we can talk about a lot of different industries, but we want to make use of the technology to help solve a problem that the customer really has. And I really believe in predictive maintenance and, allowing our machines to continue operation. So the importance of getting data out of those machines so they can make intelligent decisions about it, goes across the whole world.
Well, and beyond that, Tom, I mean, both of us, you put OPC out there, and it's been widely adopted. Fortunately, Andy and I, it took us a while fighting with IBM lawyers, but we were able to keep it open, and we put it out there. And I think it's the fact that we're continuing, even the Sparkplug spec, we're putting that out as an open source through the Eclipse Software Foundation. So I think this mentality of open standards, and you saw that in the inductive automation, all of the open standards that they're adopting. And I think going forward, if you're doing anything proprietary in the world of OT, I don't think it's going to survive.
Yeah, you don't. The days of the proprietary technology are over. I mean, there are some things that still happen in the consumer world that are a little proprietary. Unfortunately, my Apple phone doesn't talk to, somebody else's Google phone very well, but, eventually that'll change. Enough
So-
end users pound on them.
So almost towards the end, but I had another question was if you were talking to someone that was greenfield, they just starting from scratch, how would you suggest that they got started in terms of the open standards? Should they build on OPC UA, whether they build an MQTT, do they just take a platform like Ignition? How
Well,
do you think they should start?
so who's the audience for that question?
Well, the manufacturer that's doing this greenfield project.
Okay, I would say, and Tom can jump in, but there's several. Ignition, you can download it and do everything you saw in that demo yesterday for free. You can run it. It times out after 2 hours. You can reset the trial. It's got OPCUA. It's got MQTT. Now, if you don't want to do it with Ignition, you could download Node-RED. And Node-RED, same thing. It's a little MQTT machine. It does Modbus. It does Allen Bradley. It does OPC. It does MQTT. I go to colleges and talk a lot, and it's funny. I'll be talking to an engineering class, and I'll say, "So, how many of you engineers that want to go into automation have ever heard of OPCUA? Raise your hands." It's crickets. How many have a Raspberry Pi and you're running Node-RED and talking to Alexa and publishing MQTT messages, like this? So that's the other thing is that, and OPC wasn't sequestered in the industrial sector on purpose, but one of the reasons I started CirrusLink is that we invented MQTT for the industrial real-time mission critical, and IT started, they kind of stole it. So then now I'm seeing, MQTT and AWS IoT Core, MQTT and Microsoft Azure, MQTT and Google Cloud Platform. And it was like, well, IT kind of hijacked this whole MQTT thing. So I'm going to start a company and try to get it back down into OT again.
So, and it's not a rebuttal, but it's a little dynamic. So, it depends on the scenario. You got a bunch of devices that you're going to go use, okay? You've got to find out what do those devices support? How can I talk to those devices? I mean, clearly, if the device supports MQTT at the lowest level and it can publish data, perfect. If it doesn't, then, we've got to use a different approach. And that's typically where OPC and OPCUA are. And then, as Arlen said, you got to buy a product from somebody, or it's embedded in the product you're going to use. So what all we want to do at the end of the day is we want to be able to get data from everything.
Mm-hmm.
We don't want to limit it, right? I want to get data from your vehicles. If you think about, the way all these autonomous vehicles are run, it's all about the data they can get. They need all the data possible from every single sensor. The same is true in manufacturing. The same is true in mining. The same is true in pharmaceuticals.
Mm-hmm.
If I can get all the data, then we're in good shape. So you need to just, look at all the different devices you have.
But you've got to get it contextualized, and you've got to know it's a single source of truth. That's the problem. Is like Tom said, garbage in, garbage out.
Yep, absolutely. And plus the volumes you're dealing with, you've got to do some filtering at the edge, otherwise you just.
Yeah, the report.
Bill is
the report by exception is tremendous. I mean, like I said, I've been doing this for 48 years, and still today, if I tell somebody about MQTT, and I can say, well, it's report by exception, so until something changes, it doesn't publish it again, and it just blows their mind because we still have this mentality in industrial that it's industrial, we must poll. Every time we want something, we have to ask again because MQTT has a session. So when we get that, we've got a session with the device, and we got TCP, and we don't have to send it again. With Modbus, or Allen Bradley, or whatever, you poll, you get the temperature. But what is it now? Oh, I got to poll again. Well, what is it now? I got to poll again.
So with OPC, what happens is you create an OPC server that does exactly that. It continues to poll the device underneath, okay? But then the OPC server only, sends the data up to the requesting client when it changes. So there's, it does reduce the amount of data that the client has to deal with. But as Arlen said, the OPC server is constantly having to talk to the underlying data source, right? And then it has to do the intelligence of evaluating if the data has changed or not. And it's done, and sometimes you don't want the fluctuation, like a floating point number. I don't want it unless it's within a certain column. Don't overload me with more data that I can deal with.
Dead bands, yeah.
Am I allowed to ask another one?
You can ask
Um,
any question you want, Michael.
I'm just wondering what you guys think of, because I hear about Kepler a lot, that it was sort of the Swiss Army knife for this stuff, right?
Yeah.
And now TGI. Do you guys think that that's sort of the end? Do you think that it's going to continue? Do you think everybody's going to have to scramble to something else?
Yeah, Tom's better. I'm going to beg out on that one.
I'm gonna beg at it.
Yep.
So I love Kepler. I thought they were a great company. I knew the founders of the company when they first created the thing. I mean, I knew the guys in Portland, Maine. I visited them. They were a great company, and they did a better job communicating to Alan Bradley Rockwell than Rockwell could communicate from himself. It was crazy. You know, then they got sold to PTC, and there's some things there. And the only thing that's constant in our industry is
It's
change.
change.
And that's all I can really say. I can't predict the future of what's going to happen. I know Walker Reynolds has his share of opinions on what to go do. Uh, but I think, maybe one day all the Kepler technology will become open source. You never know. When I did OPC, against my board of directors, advice, they're like, you just open source. We thought we had this model. You have to be a member to get the technology. So I made the specs available for free. We open sourced all our technology, but I was more interested in adoption. So, maybe one day all the Kepler technology will be open source. Who knows?
One could dream, right? One
Yep.
could dream.
Who knows?
Or let me the alternative is protocols go away. We don't need Kepware, and all the devices publish their data.
There you go.
That's even embarrassing. The only problem is a lot of these systems out there that still have things.
Oh
that
no,
have been out there
but
since,
definitely
unfortunately,
greenfield
the
statement.
70s.
Yeah, not a brownfield
There was
statement.
one guy that approached me, and you probably don't even know what a VAX
Of
1170
course
is.
I do.
Well,
I've
he
seen-
was
I've
telling
worked
me
on
we
one of
still got
those.
VAX 1170s in our refinery. It's like, oh my god.
That's insane. Do you have any advice to the younger engineers that are worried about, AI taking their jobs, the kinds of things they should be studying? I mean, you guys both created these standards that changed a little piece of the world, and there's got to be other things that people can invent. But like how, I mean, there's just everybody's so scared of AI stealing their job. What kinds of things do you think that they should do to stay relevant?
I learn a lot from my children. I watched how my children use different things, and I think the importance, and Arlen and I have both learned over the years, the importance of adapting to new technology. You got to at least be aware of it and know how to use it. I mean, I I think AI is very powerful. I mean, I started using it. I used to write a lot of articles, and I still do. And the beauty of it, but you still got to look at what it's producing. And remember what I said: garbage data in yields garbage data out. You still have to evaluate it. But if you look at the AI technology and autonomous vehicles of what it's doing, there's a lot of people that are scared to death to go into an autonomous vehicle. I wasn't. I want to give it a try. I want to learn. Or people are scared to death to get in a hot air balloon because well, what happens if it stops? Well, you got to give it a try.
Well, and from my standpoint, again, I started as a computer engineer, but I got lucky. I worked for 10 years for the Koch brothers, used to be in the oil and gas business. So I worked for 10 years in refinery and pipeline system. And I think it's not just if I look at what I learned, it's the fact that I know what a motor operated valve limit switch open on open is. I know what a 4 to 20 milliamp transmitter is. I know how a vacuum tube starter works, and then I know how that goes to a embedded computer that we had to burn EEPROM for, and then I know how even today with AI, you still have to have a bootloader, you still have binary code you're going to be running. So all of that knowledge has helped me go, oh, okay, I kind of understand this. I think if you got siloed down and you couldn't get that broad view of the world and technology, then you might be replaced. But I think that's way overhyped right now.
Things are just going to change. I mean, you think about videos, for example. In the old days, they had, used to watch videos on VHS or on Beta.
Betamax.
Beta was actually a much better
It
technology
was.
Yeah.
than VHS.
It died.
But guess what happened? VHS took over the world. Then we had DVDs. You know, We had CDs for music. You know,
And now we
Apple
have
created, let's
Netflix
put
and
the music
iTunes.
on, an iPod. You know, my car doesn't. I had a bunch of CDs, and I was taking a trip, and I'm like, well, I'm going to put the CDs in the car. My car doesn't even have a CD player.
Nope.
I think I
It was
found an
crazy.
8-track in
Everything's
after my
about
mom
streaming,
died. You know,
you know?
the 8-track.
Hey, I was cleaning out my barn the other day and found my first iPod, and
Oh wow!
it's been set. It's got to been sitting there for the last 25 years. And I plugged it in and turned it on,
Nice.
and had all my Christmas music on it, and it still worked fine.
So, you know, AI is a game-changing technology. It clearly is. There's a lot of AI tools out there. I think companies are all trying to figure out how they're going to make money off these things.
Oh,
I mean, that's the key.
so I think I got a great last question then. So, do you guys think that in 2026 there'll be a Chat GPT moment for manufacturing? Will there be the seismic shift? Would that be this year? Would it be next year?
It won't be this year,
No.
I don't think. I think we're just now getting. If you saw here, I mean, talking to your factory and using using the data through like an MCP to go find out things that you could put on a screen. That's not very automated. It's when you know what you're going to ask, that you don't have to type it in. It comes into a system autonomously, then can raise the alarm back in, and then that's fed to a human being. I think taking the human being out of the loop on safety critical is going to be a ways down the road. That's my standpoint.
I think taking the human out of the equation isn't going to happen right away.
Well, I'm
But
not
I
even
do
saying that, but I'm
believe-
just saying that it's a Chat GPT moment where where it's just there's a seismic shift in the way that we do things.
You see a lot of
I'm not saying we pull the human out. I'm just saying
I
that
think-
we operate differently.
There's a lot of companies right now that have built this functionality already in. So I can, analyze and find out what's been going on with my equipment. I've got all this data, and so I can ask it questions via, the AI
Yeah.
protocols that are
But-
built in.
But I think the
And it's cool.
adoption though, we still got a hell of a lot of brownfield, a hell of a lot. I mean,
Yeah.
I did. We've done several projects where we go try to help states with small to medium manufacturers upgrade, and I've walked through. I mean, just a few years ago, I walked through factories where it was nothing but a clipboard and a whiteboard at the end of the hall telling them what their production was. They probably didn't even know what their OEE ever was.
But you talk about AI. I gotta believe that you're using something every day that's AI related. I use, I'm not endorsing Copilot or Claude. I use these things every day. I was trying to figure out what movie was playing, and I just asked Claude, tell me what was playing. I don't have to, it's just a totally different, way of doing things now, right? I want to find out the best German restaurant. I ask Claude. Boom, done.
Yep.
I actually try and find out the good French restaurants too, but they don't exist here as much.
No, you gotta come see me in Paris.
I'll come see you in Paris.
It's been a pleasure, gentlemen. Tom,
Michael, it's been a pleasure. Thank
Arlen,
you very
been a
much.
pleasure to
Thank
meet you
you.
guys.
Thank
and to
you,
discover
everyone.
your world of MQTT and OPCUA. Hope you guys enjoyed it too. Maybe I don't know if I'm gonna have another one of these. I'm gonna try, but thank you very much, everybody.
Thank you.